recap. Okay, we're going to recap. Well, last time we talked about these, we were working on this function, right? We were working on this function, which is at alpha 19, okay? And we work out the domain and range, domain, concavity, Y-intercept, and making perfect square. And we work out the range, right? We had the range. Good morning, everyone. We have the range. And we found the minimum Y value. Okay, the minimum Y value, or minimum Y value, which is the minimum output, right, is -4. Okay, we drew the line of symmetry, and we have the line equation of the line of symmetry. And so we got our pictures, and we did a transition, and we were working on the cut, right? The vertical cut, the horizontal cut, the vertical cut and horizontal cut. Okay, we found the X-intercepts. Okay, and we have worked on number 13 and number 14. How did you guys do? Do you have any questions? And we talk about the vertical cut is the green. Okay, when the input is given, and this line, this green line is X equals to 1. Okay, the input tells us the input is 1, input is X, X equals to 1. So this green line is X equals to 1. Okay, the red line is for number 14. For number 14. Well, f of X equals to 1. F of X equals to 1. F of X equals 1. So the green is related to f of 1. Okay, so I'm going to write it here. F of 1. When the input is given. The red one is related to f of X is unknown. The output is 1. Okay, so let me change that color to red. Right, that's the horizontal cut, vertical cut. Vertical cut, horizontal cut. So at the end of the class last Wednesday, and we found the solution, and the solution are these two diamonds. These two diamonds. Okay, so let's mark these 2 points. Do you guys still remember where we were? Shall we mark these 2 points? The 2 diamonds. Okay, last time I used the cross. Okay, and after the class, I put diamonds there. And they're not as nicely visible, right? So let me do, maybe we just do the dots. Do you think? Shall we do the dot? Okay, so let's do the dot. Let's do the dot. The dot might be better. You guys see the dots, the 2 dots? Can you mark these 2 points? These 2 points, these 2 red dots. And this dot. Okay, let's see the solution we got. What was the solution we got? Hold on. The solution we got are these 2 points, right? These 2 points. So let's mark these 2 points here in the picture. Okay, let's mark these 2 points in the picture. Are you ready? So this point is -1 minus √5. That's the input, and the output is 1. And this point is -1 plus √5, comma 1. Okay, this is green. Is x equals to 1. When we try to do f of 1. And this red broken line is the output. Okay, let me write the red. F of x equals to 1. The output is 1. Is everybody clear about this? Hello? Could you guys say something? You know, if you can show your video, you go ahead. Okay, I just cannot show my video. For some reason, Zoom says it cannot detect my video. I think I'm going to reset my computer, maybe re-log in after today's class to see that will come back up. It has disappeared since last Friday when I was attending a meeting. Maybe the webcam is broken or something. Maybe I need a new laptop. But anyway, so does everybody follow me? We did a number 13 and 14. We did number 13 and 14. So these are the 2 points. Okay, these are the 2 points. This point and that point. So please take that note, okay, about vertical cut or horizontal cut. Hello, everyone. You follow me? Welcome, Madison. All right, everybody follow me. So please write it down. Last time, this is where we were, okay? We were at number 13, question number 13 and number 14 on alpha 19. Alpha 19. Alpha 19, question number 13, question number 14. That's where we were. And are you ready? And then we're going to go on to 15 and 16. 15 and 16. (15 and 16). Are you ready? All right. Nobody said anything. Are you guys there? All right. Okay, 15 and 16. So we understand these horizontal cut, vertical cut. Okay, so I'm going to clear all of these and we're going to move on to the next question. Okay, we're going to move on to the next question. I'm going to take this picture with us. And we're going to the very top. We're going to go to the very top. Okay, so continued. Okay, on alpha, number 19, from question number 15. Question number 15. We're going to study 15 and 16 together. 15 and 16 is, 15 says evaluate. F of 2. 16 says solve the equation f of x equals to 2 for x. So once again, what is the meaning? What is the meaning? Similar, right? It's very similar to numbers 13 and 14, but this time I want you guys to be more involved in finding the solution, For f of 2, of course, we have this function, right? F of 2, we just simply plug in f, the input was 2. And we calculate, right? It looks like we have a 4 plus 4 minus 3, we have a 5. That's f of 2. F of 2 is 5. F of 2 is 5. What does it mean? It corresponds to a point 2, 5. This point is on the curve, and it's a consequence. It's a consequence of drawing a vertical line, x equals to 2, okay? Geometric meaning, okay? Line x equals to 2 crosses the parabola. Okay, so how does that work? Wait, this time the line. Okay, so we're going to draw a vertical line. Okay, and this time is 2. Boom. So this line was x equals to 2. Okay, so let me make it just a little bit. X equals to 2. So this second line is x equals to 2. Green line. The second green line is x equals to 2. Right? Do you guys see that? So this one is x equals to 1. Hold on. Sorry about that. I'm kind of clumsy with using. This is x equals to 1. I'm going to use the green. Come on. I try to use a color coordinated. Okay, so that I hope that helps. Okay, x equals to 1. That's for f of 1. X equals to 2. That input equals to 2. Do you guys see that consistency? And this vertical line x equals to 2 cross the curve at a point. At a point right here. And this point is 2, 5. Does everybody follow me? That's the meaning. That's the meaning. That 2, 5 we just wrote down is the vertical line. I'm sorry, I think I might have confused you. Okay, let me redo this. Hold on. Oh, hold on. Okay, I need to put this behind. Okay, I don't want to confuse you. Okay, did I confuse you in any way? No? Yes? Did I? Because we were just explaining what is f of 2. What is f of 2? F of 2. Well, I know I put the picture in the wrong place. This one. Okay, for number 13, we did f of 1. So that's x equals to 1. So this line crosses the parabola. For number 15, we have x equals to 2. How do I know x equals 2 is a line? Because it tells me f of 2. So this tells me x equals to 2. X equals 2 is a vertical line. And this line crosses the curve right here. And so this point, 2, 5 is right there. Okay, so let me use the green. Does everybody follow me? You see the consistency? Do you see the consistency from what we did last time to what we're doing right now? Now, you follow me? Okay, f of 2, number 16. Okay, 16. Can you draw that f of x equals to 2 on your paper? On your paper. Do you know what to do? You guys know what to do? That's going to be a horizontal line, right? That's going to be a horizontal line. It's going to be a red. So now, okay, did you guys write this down? Please do. Okay. And next, number 16. Okay, maybe I can make these a little smaller so we can do a comparison. Okay, so we can do comparison. Okay, so f of 2. So here I'm going to condense a little bit and show them, let them show on the same screen. And just to show a bit more on one screen for comparison. So for number 16 is f of x equals to 2. And this time is the y equals 2, is the output equals to 2. So the output equals to 2, meaning that we have 2 y equals to 2 cutting the parabola right here. So the second red line, and this red line indicating f of x equals to 2. Okay, so I want you guys to mark these pictures. Okay, I want you guys to mark these pictures. Let me do a little bit adjustment to make more space. Okay, make more space for the marking. Okay, so the first red we did, that was for number 14. Number 14. Okay, and that is f of x equals to 1. This one, this new one we drew is f of x equals to 2. Okay, one is y equals to 1, the other one is y equals to 2. Does everybody follow me? Okay, so now I want you to mark all the green and the red in the picture, in your paper pencil. Okay, so I'm going to give you some proper marking. Okay, so just 1 second. Okay, I'm going to start doing this, and you're doing that at the same time. Okay, so one is, this is going to be y equals to 1 for the line we had before. And that's going to be at -5, 1. And the font, make it red. Let's see if they give us a good look. Okay, y equals to 1, right? The next one we're gonna mark is y equals to 2. Y equals to 2. I'm gonna put it at still -4, 2. And red. It's very important that you mark these correctly. Okay, it helps with understanding. Y equals to 2. Do you guys see that y equals to 2? Y equals to 2, and the green one is x equals to 1. I'm going to make this 0.5. And that's going to be a 4. And we're going to use green. Am I spending time? I'm spending too much time here. Do you guys follow me? I'm always just worried that you guys may not follow me. Okay, so this green is x equals to 1. Okay, and I'm going to mark one more time for the x equals to 2. X equals to 2. So I'm going to put it at 2. And y I put at 7. The font is going to be green. Okay, we want those to be there permanently instead of just sometimes disappears, right? X equals 2, x equals to 1. For x equals to 1, I'm going to just move it a little bit to the center. Okay, so let's do the 1. Is that better? Is that better, everybody? So for, you can see they give you numbers, whether it's f of 2 or f of x equals 2, it makes a big difference. That's what I'm trying to show here, okay? So now for 16, you can see the 16 crosses the curve at 2 places. Okay, at 2 places. Okay, so I'm going to make this just a little bit this way. No, just like that. Y equals to 2. That's y equals to 2. Okay. Does everybody see everything clearly? Do you need to? Do you want me to clarify anything? So for y equals to 2, I should make it a little bit higher because I see that you guys. So maybe 2.1, because I see that red line blocked it. Okay, so y equals to 1, y equals to 2, x equals 1, x equals to 2. Okay, that's pretty clear. So next, we want to find out these two points. Is that clear, everybody? That's the thing we want to find out. Gee, I'm sorry. Hold on. Okay. There, we got it. We want to find these two hearts. Okay, the location of that two heart. And how do we do that? We can either do, because this is f of x equals to 2. And what is f of x? What is f of x? F of x, there are two forms, right? One is x squared plus 2x minus 3, right? That's one form. And 2x also has another form. The other form is the perfect square one, right? X plus 1 squared minus 4. So we have two forms. Which one do you want to use, right? And we've been using this letter form. So let's use the letter form to be consistent. Okay, so we use this form. So that's what we get from f of x equals to 2. You guys follow me? Okay, and then we're solving for x. So we're solving for x. Solve for x, right? Because we're solving for x. Y is no, we're solving for x. Output is given, we're solving for input. Okay, so how do we solve it? Okay, alpha 11, remember alpha 11, right? In those sections, we've done that. So we're gonna add 4 on both sides. And that equals to 6. And we're gonna take square root on both sides. We're gonna take square root on both sides. Okay, and then what? The next line, whoops. We'll come back to it, okay? We'll come back to it. And the next step, we get the absolute value of x plus 1 equals to square root of 6. And then what do we get? X plus 1 equals to plus or minus square root of 6. So in the end, we get x equals to, we subtract 1 on both sides, plus minus square root of 6. So x is equals to negative 1 minus root 6. So we have 2 x's. We have 2 x values. One is, we can call it x sub 1. That equals to minus 1 minus root 6, right? And the other one will be x sub 2, if you want to do that, x plus 2 plus square root of 6. Okay, and these two numbers is the consequence of setting f of x equals to 2. So we get 2 points. 2 points. And so what are these 2 points? These 2 points, we have the same output, different input. Sorry, what did I do there? Minus 1 minus root 6. Okay, and the other point is minus 1 plus root 6. So these are the 2 points. Does everybody follow me? So these are the 2 points. So let's go back to the picture. Let's go back to the picture. Okay, let's go back to this picture. Where do we put those 2 points? Put those 2 points. Those are the 2 hearts, right? Those are the 2 hearts. So we're going to put the 2 points on the chart. Okay, so that's 1. So we're going to put what color? We should still use a red, a dot, another one, dots, 2 dots. You guys see the 2 dots? You guys see the 2 dots? Can you mark these 2 dots? You see this line gets a little busier. This line gets a little bit busier. Okay, I'm going to clean up a little bit. Okay, I'm going to clean some of these pictures as you're marking. So I'm going to mark it on a clean one. Okay, so I'm gonna remove some of those pictures, so some of those lines. We keep that. We keep that. You keep that. Okay. We keep these. We delete that. Delete that. Delete that. Delete that. Let's see what do we get. This is a cleaner. Okay, this is a cleaner. Okay, one more delete. Okay, I'm going to delete those once. X equals 1, delete it. Y equals 1, delete it. Okay, we just don't want it to be too busy. Is that clear? So this is X equals 2, Y equals 2. Do you guys see that? So now I want you to mark these two dots right here. Does everybody follow me? I'm going to have to make this temporary because the software doesn't give us a very good picture doing that. Okay, so this point will be -1 minus √6, comma 2. And this point, okay, this point is -1 plus √6, comma 2. You see, the points are not always nice and neat. Not always nice and neat, right? Okay. Is that clear, everybody? So we did a 3 pairs so far: 11, 12, 13, 14, 15, 16. How was it? You guys think you understand? If you do, let's try number 17 and 18. Let's try number 17 and 18. Ready? Could you try number 17 and 18? I'm going to give you a couple minutes. Please try number 17, number 18. You're going to do the vertical cut and horizontal cut and find the points of intersections. Find the points of intersections and see what we get. Let's find the point of intersections. See what do we get. Five minutes. 5 minutes. I'm sorry, guys. Today, and actually since last Friday, my Zoom have lost the video. When I try to start the video, it wouldn't start for me. So I cannot show you my fresh new haircut. That's really bad. So no matter how many times I try, Zoom is just doesn't detect my camera. I don't know what happened. It could be my camera is broken. I certainly hope that's not the case. How did it go? How are you guys doing? So hopefully this is a cleaner state, a cleaner slate. Okay, so this is the situation of the cut, right? This is the situation of the cut. One is a vertical cut, and one is a horizontal cut. And for f of a -5, and this is going to be the line of x equals to -5. Let me make a little adjustment. It doesn't look very best. Okay, x equals to -5. So I'm going to make just a little, scoot over a little bit. Okay, x equals to -5. Okay, there's a little negative sign there. And this horizontal one, y equals to -5. So this is the vertical cut for number 17, and this is the horizontal cut for number 18. And what's interesting is, do you think the green vertical line will touch the curve? Will it touch the curve? Could someone say something? Do you think the green vertical line will touch the curve? It doesn't seem to touch it right now, right? Do you think it won't touch the curve? Well, you think it won't? If I just change the view to be more, it will actually touch. It will touch because the domain is all real numbers. Okay, the domain is all real numbers. Okay, it will touch the curve. The green will touch the curve. Just because it didn't show there, it will go indefinitely higher and higher. So it will touch the curve. It will touch it right here. We just have to identify that point. Okay, we just have to identify that point. How about the red? Do you think the red horizontal line will touch the curve? Madison, do you think the red horizontal line will touch the curve? No, that's right, Marcelo. You got it right this time. The red horizontal line will never touch the curve. Therefore, we should not expect a point of intersection, right? Like we used to. So let's find out what are these points. Okay, so let's find out what are these points. okay? For the point that's with the green touches the curve, that's easy. We just have to plug in, okay? We just have to plug in x squared plus 2x minus 3. Now our x is -5, so we're going to replace x by -5. There. And we will get a point. What do we get here? What do we get here? What do we get here? We have a 25 minus 10, right? 25, positive 25 minus 10, and minus is 3. So we get what? We get a 12, right? So what is that point? What is the point here? That point is -5, 12. I can put that point right in the chart, right on the chart. Okay, let's make it a dot. And it's a green dot. It's a green dot. Okay, and can you mark that point? Can you mark that point? That point should be -5. The input, the output is 12. Okay, so it's at a -5, and that point is 11.75. And I'm going to make it a green color, right? Why not? We want to be color coordinated. 5, 12. 5, 12. Now, the red one doesn't touch the curve. Okay, so we should not expect any point of intersection. So let's see if we go through the steps. Oh, I messed up again. I should put this picture. Sorry, I should put this picture right here. Okay, for 17. So that dot is 5, 12. And next, we're going to look at the points. What if we follow the routine, right? What if we follow the routine of doing f of x equals to -5? And we're going to still choose the perfect square part, right? X plus 1 squared minus 4 equals to -5. What do we get? Okay, so we're going to add 4 on both sides. We add 4, we get -1 on the other side. And we take a square root on both sides. Okay, so we take square root on both sides. And on the left-hand side, we still get an absolute value of x plus 1. On the other side, we encounter a square root of a -1. That is interesting. Have you guys seen square root of a negative number? Has any one of you seen the square root of a negative number? It is no longer a real number, right? It's called complex number. For complex number, we cannot graft it in the rectangular system we have right now. We have to have a new system. So, and this square root of -1 is called I. Have you guys heard about it? Had any one of you learned it? This is an indicator, okay? This this is the indicator. Is the indicator that the line, okay, y equals to -5. Oops, sorry. Does not touch the parabola. Okay, so even if you don't graph it, or you just work it, this is the algebraic this is the algebraic indicator. This is the algebraic indicator that there's no touch. Whenever you get a complex number, geometrically, it tells you the curve does not touch. Okay, the horizontal line, the red, does not touch the curve. No touch. When there's a complex number, there's no touch. Did you hear that? So there's no point. Then you would say, you can still go on. Okay, some of you might have learned the how to handle complex numbers. So this is still equals to plus minus I, and x is equals to, regarding I, we're not going to process this extensively, but I just want you to see that you still process it similarly. But this tells you no real number solution. We have two complex number solution, no real number solutions. I mean, no intersection. No intersection. Okay, no real number solution. We have two complex number solution. So there's no point of no intersection on the graph. Okay, so this is the algebraic indicator that the line does not touch the parabola. That's number 19. I'm sorry, that's number 18. Does everybody follow me? Do you need to do more? Not yet. Not yet. Okay. And next, we're going to move to number 20. We're going to move to number 20. Okay, we have lots of questions. I think today we're going to finish. Okay, we're going to finish and do some more. Okay, number 20. Number 20. Wait, number 19. Sorry, number 19. What does it mean? Number 19. What does it mean? Okay, number 19 says solve for. Okay, it's solve for f of x equals to x squared. Okay, we're familiar with that. X squared plus 2x minus 3. Number 19 says greater than 0. What does that mean? Meaning, what does it mean? It says solve for x, right? Solve for x colon, right? What does that mean? It means that as input is unknown, this function, you know, we have this function here, and we got output, of course. For every number from the domain, we have an output. But we want the output to be positive. We want positive output. Positive output. Positive output wanted. Positive output is wanted. We know a function corresponds to a picture, right? we understand a function corresponds to a picture, and we have this picture. Okay, we grab this picture. Let me grab that picture we have done before. Okay, I know we have it before, right? Right here. Okay, I'm going to take this picture and I bring it with us here. So still understanding the meaning, we want the output positive. Okay, so where do we find positive output? So what are the output, right? We know output are vertical values from the curve. For example, for this input -2, we have an output. This is an output. What is the value? I can find out the value, right? I just plug in f of -2. But I know from this picture, f of -2 is going to be a negative number because you see the vertical line is beneath x-axis. So this is negative output. Another input, right? If I grab another input, right? Whatever it is, it seems to less than -1, less than, I'm sorry, greater than -1. So this is the output. This output is negative, isn't it? Because it's beneath x-axis. So this is again is a negative output. For another input here, suppose this is my input, and that output is positive. And this point, the output is a positive. Do you guys get the hang of it? So the part of the curve that's above x-axis, those are the indicators that you have positive output. Positive output. And where do you find the input? The input is by drawing the vertical line. And you get those points. So all of these are positive output. Do you guys see that? All of these are positive output. Until here, okay? So now we have these 2 points. Because we wanted a positive, what happens on those, on the 2 red dots on the x-axis? They should be circle. Okay, so I'm going to change them to circle. I'm going to explain to you. Okay, I'm going to explain to you why. And there's another one, sorry. That make a circle out of that. Why these should be circle? Because when input is -3, the output is 0. 0 is not a positive. Therefore, -3 should not be the solution. So now let's look at our solutions. Our solutions would be, you know, just to get all the positive output, and these are the input that will guarantee our positive output. Do you follow me? And number 19 is asking us to give us all the input such that the output are positive. Do you guys understand now? We understand now. Okay, so let me clean this up and explain it to you one more time. Okay, this piece indicate positive output, and that piece indicate positive output. And this piece, however, okay, this piece, okay, this piece indicate negative output. And this question number 19 is asking for all the input. Okay, X is standing for input. All the input such that the output is positive. You see, we want the output to be positive. Okay, we want positive output. So solving for x, f of x equals to that is positive. That's what it means. So we're looking for all the input. And where do we find those input? Right here. All the way up to a little less than -3, and all the way up to a little bit greater than 1, and then forever to both directions. So the solution for input would be x less than -3, or x is larger than 1. You guys follow me? So that's the solution to number 19. So once you have that picture, okay, so once you have that picture, okay, do you get it? Yeah? Yes? Red, thick. Okay, so all of these numbers, not including -3, and all of these numbers, not including 1. So these are the solutions. So once we understand the meaning, do you guys see? Once we understand the meaning, the answer is obvious. Any questions? Any questions? Now, how about number 20? How about number 20? If we understood number 19, number 20, instead of we want positive output, and 0 output is also wanted. 0 output is also wanted. So if that's the case, we just have to include these 2 dots, which makes 0 output. Okay, so this, instead of making them making them circle, I'm making them dots. And the solution would be, instead of less than, it's going to be less than or equal to, or greater than or equal to. Do you guys follow me? So let's look at 21 and 22. 22 is asking for negative output. 22 is asking for negative output or 0 output. So 21 is asking for negative output. So, okay, so 21 is asking for what? Negative output. So what will be the solution? It will be the opposite of number 19. Will be the opposite of 20, right? But anyway, so so this is no longer true. I will have to make some corrections. So less than, hold on. So this is going to be less than. So this is going to be circle, delete. Okay, adding between -3 to 1. And this is going to be inside here. Hold on. Here. So -3, 0, 1, 0. and make it thick. That's number 21, right? And how about number 22 then? So let's look at the solution. The solution would be, does everybody follow me? The solution would be -3 less than x less than 1. Okay, just these. Number 22. 22, we want the output to be negative or 0. So instead of less than 0, we have less than or equal to 0. So we want a negative output or 0 output. And this same picture will be just modified a little bit. We turn the circle into dot. Does everybody follow me? Does everybody follow me? Yeah? Good. I'm kind of going slowly, but I don't want you to get bored either. Okay, sometimes you can say, oh, this is so slow, I'm bored. I'm taking a nap. Well, when by the time you come back from the nap, you're behind. Okay, so let's summarize. Summary. Okay, summary, which is from number 19 through number 22. Number 19 through number 22, and then we take a break. Okay, summary, these four cases. So I'm gonna make 4 columns. Okay, so what are these cases? Right, these 4 cases. Solve for f of x larger than 0. Right, this is one larger than 0. Solve for and then solve for greater than or equal to 0. Right, and less than 0. And less than or equal to 0. Less than or equal to 0. So we have these 4 cases. In each case, we have a picture. Okay, so let me make this just a little bit smaller to see if we can hold it all in one picture. Okay, so for larger than 0, we want the output to be larger than 0, right? So that's the picture we got. That's the picture we got. Right? So positive output. Positive or 0. Right there. Oops. Didn't copy it. Copy, paste. Okay, less than 0. Right? Less than or equal to 0. I hope this will be a good comparison for you to see. Okay, and the solution, oops, sorry about that. Okay, I'm gonna delete some of the rows because they're in my way. And okay, so in this case, the solution is x less than -3 or x is larger than 1. And for greater than, for positive or 0 output, and this is going to be less than or equal, and this is greater than or equal. And this case is a -3 less than x less than 1. And this other case will be -3 less than or equal to x and less than equals to 1. Okay, So these are the 4 cases in comparison. And you can see the idea is very consistent. The idea is very consistent, right? You just, you just recognize this is the positive piece, that they're all the same picture. These are the positive piece. So when you ask for positive piece, you just give the input for the positive piece. And these are the negative piece, negative. And how about the dots? 0 output. So positive output, negative output, 0 output. So it depends on the question asked. You just answer that question. You just answer the question. Does that make sense, everybody? Any questions? So sometimes the output is given as a positive. Sometimes the output is, we want the output to be positive. Sometimes we want the output to be negative. Sometimes we want the output to be 0. As when we ask the output to be equal to 0, we're looking for X-intercepts, right? Yes. All right. So in all of these pictures, actually the Y-intercept point there is really not necessary, but I just leave it there so I can totally take it away. It's not necessary. It's not necessary. But anyway, I'm going to have you guys take a break, and I'm going to take a break as well. Let's take a break and come back at 12. Okay, so let's take a break. Back at 12. Okay, and I will see you guys. Zoom recording. Do we have any questions? Hi, Alan, Francesco, Medicine, Marcelo, and everybody else. Yes? Yeah? Yes? No questions? No questions. Okay, everything's easy, right? So far, so good. All right, so let's move forward. Now, let's look at the remaining 4 questions in this section. Okay, so let's look at the remaining 4 questions in this section. 23. Okay, it says solve for x, where x squared plus 2x is larger than 3. What do we do? What do we do? How do we solve that inequality? You might notice that if I subtract 3 on both sides, subtract 3 from both sides, what do we get? We get x squared plus 2x minus 3 larger than 0. Does this look familiar? Isn't this question the same question here? So this question, number 23, is really number 19 in disguise, isn't it? Why we have all these variations, right? This is because the 6 principles, okay? You can add the same number on both sides, subtract the same number on, same number on both sides, and all of these manipulations will cause that sometimes the inequalities or equations, they look different, but they may actually the same equation or inequalities. Okay, so this question in disguise is number 23. Of course, this is just one form of disguise. You can have different disguise. Okay, so the solution would be what? Will be the same as number 19. Okay, so now if you look at 23, 24, 25, 26, okay, I will continue this table. Okay, and of course we know the solution is here. Okay, so I'm going to add a column. I'm going to add a column. I'm going to add a row, sorry. I'm going to add 2 rows. Questions. Okay, same questions in disguise. It's not we're trying to, try to camouflage anything. It's just sometimes the algebraic form could be different. Okay, for example, it could be x squared plus 2x greater than 3, right? And the same questions in disguise could show up in different forms. Okay, questions in disguise and question in disguise. So here I give you just one form of disguise, right? It could be x squared plus 2x greater than or equals to 3. And it could also be less than 3 or less than equal to 3. So all of these can be questions in disguise. But we all transform them into the form of 19, 20, 21, 22, right? So let me give you just another example of questions in disguise. Okay, I can totally write this as x squared larger than 3 minus 2x. Could I do that? Of course. If we move everything to the left-hand side, you're going to get exactly the same question. Okay, these are just a typical algebraic manipulation. Okay, and I could have 2x greater than equals to 3 minus x squared. Could I do that? Of course. Okay, and for this one, I can even write it as 3 larger than x squared plus 2x. You guys see that? These are all different ways you can manipulate the same question to make it look different, but they're really a question that you could transform to something we are familiar with. Okay, and then lastly, I can even make it this way. I can make it like 2x minus 3 less than or equal to a negative x squared. Look at that. Okay, so these are all different. They're all questions of this. They're all the same question of their category, but they're just in different shape and form. Different shape and form. Okay, and they all mean the same thing if you transform them to compare with 0. To compare with 0. Aha, you got it? Any questions so far? If you don't have any questions, we're going to get to alpha 20. We're going to get alpha 20. No questions. Is it still, you still have no questions, guys? So let's look at alpha 20. Okay, let's look at alpha 20. Alpha 20, we have several questions. Well, 26 questions still. We still have 26 questions. But the second time around, I hope it will be easy. Okay, so let's move to alpha 20. And this time I want you guys to have a lot more hands-on. Excuse me. Alpha 20. Alpha 20. Okay, so then this time we have this quadratic function. Okay, which is x squared minus 2x minus 3 minus 2x minus 3. Okay, so we're going to go through these 26 questions. The first one, domain. What is a domain? Come on, guys, please participate. Okay, the more you do in class, the better you're going to understand. Yes? So what is a domain? What is the domain? Yeah? Domains are real numbers, right? Are you guys there? Yeah? Hello? Is it concave up or concave down? It's a concave up. Why? Because the coefficient of x, the leading coefficient is a equals to 1, which is a positive, right? Concave up. Number 3, y-intercept. What is y-intercept? F of 0. So we set x equals 0, right? And that's equals to -3. So y-intercept is what? Y-intercept, we have only 1, right? Because of function, right? The input, for each input, there's only exactly one output. We cannot have more than one output for the input 0. Therefore, we only have one y-intercept. Number 4, completing a square. So this time, you guys are going to take the lead to complete the square. Completing a square. Completing a square. What do we get? How do we complete that square? X squared minus 2x minus 3. What can we do? Complete that square. We're going to add a 0. So what form of 0 are we going to choose? Anybody would like to contribute? Francesco? Marcelo? What do you suggest to make a perfect square, to make a partial, to make a perfect square as part of the quadratic function? What would that be? How would you do it? Yes? No response. Hey, you guys, are you guys there? Medicine? What would you do to complete a square here? Alan? Alan? Are you guys there? No answer. All right, so I'm gonna do it. Well, you guys can watch the recording. Okay, so I'm adding one, subtracting one, and the first three makes a perfect square. That's gonna be x minus 1 squared. And minus 1 minus 3, that's gonna make minus 4. Okay, so can we identify the vertex? Right, so can we draw the picture from x squared? Right, from x squared picture, can we draw the final picture for this one? Even though I have given you the picture, but we still want to go through that process of transformation, right? Of transformation. So for x squared, that's our x squared. That's our x squared, right? From this x squared, okay, so I'm gonna make it just a little bit smaller. And from x squared, we're gonna do, what are we gonna do? We're gonna do from x squared, we're gonna transform to x minus 1 squared. So that transformation is a shift to the right by 1 unit. It's a horizontal shift. So now we're gonna shift from x squared to x minus 1 squared. Okay, let's make it green. There. Okay, it's shifted. Okay, so let me make some adjustment. And next, of course, we're gonna shift one more time, which is minus 4. What would that be? Right, so I'm gonna make this the view to be 7 here. So this is gonna be 7 shifted. Okay, so the x squared is shifted right by 1 unit. And let me make this adjustment on the, okay, so I hope this is better. Okay, so this is going to be 8. Okay, you see that horizontal shift, right? From x squared to x minus 1 squared. And then one more time, we're going to shift it to x minus 1 squared minus 4. So this is going to be a vertical shift. And this vertical shift, okay, is going to be the final shift. Okay, so this is vertical shift. We shifted down by 4 units. Whoops. Okay, we shift it down by 4 units. Okay, so make it red. So that's our final curve. That's our final curve. So tell me, what is the vertex? Can we identify the vertex? That's question number 5. So among all these shifting, right? Among all these shifting, the vertexes shift along with it. So we shift right by 1 unit. So the vertex is here. Okay, you can see the shifting from here to there. That's shifted to the right by 1 unit and shifted down by 4 units. So what will be the vertex? The vertex is going to be 1, 4. Do you agree? -4, sorry, -4. Okay, so that's our vertex. That's our vertex. Okay, the vertex is 1, -4. So we got the vertex. Now we can answer some questions. We can answer some interesting questions. Does the vertex tell us when the input is 1, the output is -4? And that is the lowest point. That is the lowest point. So now we're going to answer a couple questions. The next question is, what is the range? Obviously, this parabola opens up and the lowest point is 1, -4. The range is about the output. So the output would be bracket, parentheses, from -4 all the way to positive infinity. Or, okay, in some of our preferred form, okay, I've been promoting these preferred forms, right? You can say f of x, this f of x is greater than equals to -4. And you can also say, okay, f of x in this form greater than equals to -4, right? That's f of x, of course. Okay, for any real number x. So all these are, and this of course is the most difficult and is most preferred. Okay, the most difficult and most preferred. Oh no, what's going on? Okay, do that. Let me box it. Okay, boxed. Okay, so that's a range. Now, the minimum or maximum y value. So number 7, the minimum or maximum y value. Because this parabola opens up, we don't have maximum value. We have minimum y value. And that is -4. Okay, minimum y value, that's -4. Okay, and number 8, along this way, can we draw the line of symmetry? Can we draw the line of symmetry? The line of symmetry obviously had shifted, right, to the right by 1 unit and shifted down. So the line of symmetry is really just what? Is that vertical line? Okay, I make it broken. That is a line of symmetry. Okay, so we can draw the line of symmetry. And now, what is the equation of the line of symmetry? The equation of the line of symmetry, apparently, equation of the line of symmetry is what? Is x equals to 1. Okay, x equals to 1. So this, once we get the perfect square, okay, when x equals to 1, which makes this perfect square part equal to 0, and x equals to 1 is the line of symmetry. Line of symmetry. Any questions so far? Okay, I think we can do all of these questions today, so we can finally put together, right? Because when we did alpha 19, it took us multiple lectures to finish, right? We did it last Wednesday and today. So now we will do this whole question completely till we have a better understanding. So number 10. Number 10. Let's find the x-intercept. Okay, let's find the x-intercept. X-intercept, we may have multiple. We may have multiple. So now we finally have the curve. Okay, so I'm gonna just have this curve with us. Okay, we have this curve with us, and that's it. We have identified the line of symmetry. So we're going to put this information in place. It looks like we have two x-intercept from the picture, right? We have two line of symmetry in the picture. I'm sorry, we have two x-intercepts. So make this, that's the picture. That's the picture. Okay, so that's the curve. And what point do we have? We got the y-intercept. So let's put the picture together. I always recommend when you guys work with this kind of questions, you would like to have your points marked on a picture that's next to you. Okay, so this is a dot. Okay, that point is 0, -3. So please, let's mark it with me. Okay, so we're gonna mark that point, which is 0, -3, and that is our y-intercept. Okay, so I'm gonna mark that point at a -1 and -0.8. Okay, so that works. Okay, I hope it does. Okay, so that's the I put it a green, 0, -3. That's the consequence of the curve crossing the vertical line x equals 0. Okay, x equals 0. Right, so we're going to combine all of these we learned together and put them in the chart. It looks like we're going to have two x-intercepts. It's hard to guess them, but we can find them. Okay, so number 10, we're going to find x-intercept. What does it mean, the x-intercept? Well, that's where the curve crosses x-axis, right? So y, we said y equals 0. We have talked about this. Do you guys have any questions? And we can also use the other form. What is the other form? The perfect square one. We can use this form, right? Sometimes using this form it's much easier. So we can use the method we have used before to solve the equation. So now let's see what do we do to solve this equation? We're going to add 4 on both sides, right? So that's going to be x minus 1 squared equals to 4. And then we take square root on both sides, right? Let me move this away just a little bit. Okay, so we're going to take a square root on both sides. back here, right? So we're taking square root on both sides. Has this process become like a routine now, right? But still do it mindfully, okay? So we have this square root of something squared, and we know that's going to be absolute value of x minus 1 equals to 2. Square root of 4 is 2. And then if you like, this is sometimes we like to do this, x minus 1 equals to plus minus 2, plus 2 or minus 2. But this really means that you have two x values, okay? Maybe x1 is equals to -1 minus 2, and the other one, it's connected by or, okay? X equals to -1 plus 2. So we have -3, and over here we have a positive 1. And now we got our x-intercepts. Our x-intercepts are, what are x-intercepts? Our x-intercepts are -3, comma, wait, I think I made a mistake. I made a mistake somewhere. It's a positive 1. I'm sorry, it's a positive 1. What a bummer. So positive 1, because I'm going to add a 1 on both sides, not a -1. So 1 minus 2, 1 plus 2. Sorry about that. So this is going to be -1, and that's going to be 3. So the 2x intercept is going to be -1, comma 0. And the other one is 3, comma 0. So these are the 2 points we call x-intercept. I apologize for my mistake. Okay, so let's put the points in the graph. Put the points in the graph. Okay, one is a -1, comma 0. So we make it a red dot. And the other one, we're going to make it a red dot as well. Boom, 2 red dots. Now, I would like you guys to mark these 2 points in your notebook. Okay, so I'm going to do the same along with you. Okay, so 1 point is -1, 0. Okay, so I'm going to put it at this location, just like that. The red point. Okay, -1, 0. Okay, just where I want it. And one more, 3, comma 0. Okay, so this time I'm going to put it at 3, and this is 0.1, and I'm going to make them red. And there you go, 3, comma 0. Okay, so we got the x-intercepts as well. Now, as the next is a series of questions like we have done before. So from 11, so we're going to do them by pairs. Okay, so we're going to do the horizontal cut, vertical cut, horizontal cut, vertical cut. Okay, so now number 11. Number 11, we're going to evaluate, okay, f of 0. And number 12, okay, it says solve the equation f of x equals to 0 for x. So it's still the same story, right? It's still the same story. It says, well, if the input is 0 for 11, if the output is 0 for number 12. So for number 11, it's very straightforward because it's essentially the same as number 3. It's essentially the same as number 3. Okay, so all you have to do is just do it here. Boom. Okay, and the point of intersection we already know. Okay, and number 12 essentially is number 10. They didn't ask us for the points. They did not ask us for the point. Okay, so we set up f of x equals 0. We found the x. So x1, x2, sub x2. Okay, sorry, I missed the sub x2. Okay, sorry about that. Okay, x2. And solving for x, because this didn't ask for points, so you don't have to mark the points. But if you mark the points, it's not a big deal, right? So we know that these are same questions. It's just a different way of asking them. So let's look at number 13. 13 and 14, it's another pair, but this time it's for 2. Okay, so f of 2. So what is f of 2? Right? F of 2, of course, you can put this in the function. Either one is okay. Either one is okay, right? But this time it's 2. Okay, this is 2. So what do we end up with? F of 2 is equals to what? -3. -3. Okay, let's look at 14. 14 says solve for x, right? Solve for x, but f of x is 2. You see, one is input is 2, the other one is output is 2. So what do we do then? It's very similar, okay? So we can take whichever one you like, it doesn't matter. Okay, we have this equals to 2. We have this equals to 2. And then what you get? We will have x minus 1 squared equals to 6, because we add 6, we add 4 on both sides. And then we take square root. We take square root. We take square root. We take square root. Okay, are you guys thinking about the vertical cut or horizontal cut? Yeah. We're going to do that after we solve it, right? So we're going to have the absolute value of x minus 1, and that's equals to square root of 6. Boom. And then x minus 1 equals to positive or negative root 6. So in the end, what do we get? We get x equals to 1 plus or minus root 6. These are two, that means there are two solutions when we cut horizontally. Okay, so these are the two solutions. X sub 1 is equals to 1 minus root 6. X sub 2 is 1 plus square root of 6. Right? So now let's look at the geometric meaning. Okay, we have our picture. We have our picture. For number 13 is a vertical cut at x equals to 2. So if I draw a vertical line, could you guys draw the vertical line along with me? Yeah, let's do that. Okay, we're gonna draw this vertical line. It's broken and make it thin. That's the vertical line. So number 13 means a vertical cut. Okay, and what's the crossing? The crossing is 2, -3. 2, -3. So that point is 2, -3. Okay, so I'm going to make it a green dot right there, the green dot. Okay, so let's mark that green dot. Mark that green dot. Can you guys do that with me? So 2, -3. Right, so I'm going to have a 2 here, -3. Let's make it 2.1, just like it, have it move a little bit over to the right so for a clear viewing. So now we have these 2, -3. Oh, it's a little bit crowded, right? Can you guys see that clearly? Can you guys see that clearly? 2, -3, 2, -3. So let me scoot over a little bit. Okay, have it scoot over a little bit. Ah, it's even worse. But anyway, just give me a little more patience. Okay, so let me make it like that. 2, -3. So right, that's the vertical cut. So now let's see, what do we get for the horizontal cut? Right, for the horizontal cut, okay, we have a horizontal cut. 2, okay, it's red. Okay, I try to stay the same colored coordination. Okay, horizontal cut. Horizontal cut, obviously we have 2 points, right? 2 points of intersection. So we're going to identify these 2 points, and we have solved for 2 solutions here, right? So we have 2 solutions here. We do, right? So let's mark these 2 points. Right? With a red dot. And we have another point, of course. That's a plus. And 2 red dots. 2 red dots. Now let's mark these 2 red dots together. Let's mark these 2 dots together. Okay, one is a vertical cut, one is a horizontal cut, right? One is horizontal cut. So let's mark these 2 dots together. Okay, I'm going to use the software to mark it because with square root present, it's not going to be very nicely done with scientific notebooks. So I'm going to do, this is a 1 minus root 6, comma 2. Okay, that's for this red dot. And this other red dot is 1 plus radical 6, comma 2. See, vertical cut, horizontal cut. Does everybody follow? Consistency, right? Consistency. Everything should be very clear. Everything should be very, very clear. Can you do number 15 and 16? Can you do number 15 and 16? Vertical cut, horizontal cut again, right? Vertical cut and horizontal cut again. Good, good. Can you do 15 and 16? Can you do that pair? Yeah. 15, 16. 15, 16. All right. So I'm gonna clean this up and we're gonna do this together. Okay, we have some time left. Okay. 15, 16 together. Number 15, 16. Okay, hopefully we can finish this. It's -3, right? So instead of 2, we have a -3. Oh, come on. So this time we're getting f of -3 is -3 squared. That's a 9. 9 plus 6, that's a 15. 15 minus 3 is a 12. Right? So the point is the vertical cut give us a point -3, 12. So that's the vertical cut. That's the vertical cut. Number 16. Number 16. Solve the equation instead of for output. We want output equals to 2. We have output equals to -3. So the equation we're solving is going to be like this. Okay, hope you guys follow me. That's -3. Okay, and we're getting some interesting points. Okay, we get some interesting points. So we'll add 4. So we still add 4 on both sides. So we're going to get x squared. And this time we have equals to 1. That's nice. Okay. We usually like to have some nice, neat numbers, but if we don't get those nice, neat numbers, we can still deal with them, right? We can still deal with them. So we take square root on both sides. The square root of 1, of course, is still 1, right? You don't have to write this piece, and you can just write it equals to 1. Almost to the end, we have absolute value of x minus 1 equals to 1. Okay, and that gives us that x minus 1 equals to +1 or -1. We get some nice, neat points, actually, right? We get some nice, neat points here. And we get x equals to 1 + 1 - 1, right? So we're going to get 2 points. One is x sub 1, which is 1 minus 1, that's a 0. X sub 2, we're going to get 1 plus 1, that's a 2. So we have 2 points of intersection. Let's see what we have here. Okay, so these are the 2 points. One is 0, input is 0, and the other one, the output are uniformly -3. -3 for these 2 points. Right? Because we did the horizontal cut. We did the horizontal cut. So let's hurry up a little bit, right? One is green, one is red, right? One is green, one is red. So f of -3. Okay, so I'm gonna find a picture. Let me go ahead and use this picture. Okay, f of -3, that a vertical cut. Okay, that a vertical cut. Okay, that a vertical cut. Okay, that a vertical cut to the curve. It's going to touch, right? It touched somewhere, right? It's still going to touch at 12. Our scale is not, it need to be extended. So I'm going to change the scale to x equals to, so y equals to 15. So now you're going to see the intersection right there. Okay, so that point is -3. Okay, that point of intersection is -3, 12. And that point does have a place in the graph. Okay, so I'm going to put a red dot right there. Should I put a green dot? Let's do the green dot. Okay, let's do the green dot. And shall we mark that point? Let's do that. Let's mark that point. Has it become easier for everybody, guys? -3, 12. Okay, so that's a -3, 12. So let me take a leap of faith to see if this will work. Okay, that's a green. Come on, give me the point. -3, 12. That's pretty good, right? That's pretty good. Now, the horizontal cut. Okay, the horizontal cut. I'm going to take this picture. Okay. Just try to keep it clean. I just try to keep it clean. Okay, if we put everything in the same picture, sometimes it's just not clean. Okay, it's hard to identify. It's hard to identify. So this time I'm going to do the horizontal cut, which is -3, and this line is going to be red, cutting my parabola. Oh, look at that. Look at that. We got 0. It's already touched a point we had before. And there's another point, right? So what is this other point? So 0, -3 actually was the y-intercept, right? And 2, -3, 2, -3 is the cutting, is the other point we get there. So let's put it on the graph. Okay, I'm going to make it a red dot. Boom. Okay, so let's mark these 2 points. This point is already marked, so we just have to mark the other point, right? So that's going to be 2, -3. So I'm going to just put it here without, you know, worry about whether it's going to work or not, and I'll make adjustment just afterwards if necessary. To -3. The -3 is not very clear, so I'm going to just make some adjustment here. To -3. So how am I going to make that 2.5? It's still not as ideal, but do you guys follow me? To -3. So let me make it 2.75. Finally, okay, 2, -3. So horizontal cut, vertical cut for number 15 and 16. Is that clear, everybody? It become easier, right? So I'm going to skip 17 and 18 for you. I'm going to skip 17, 18 for you. And obviously, we're not going to finish everything today in class, but I trust you guys can finish them. Can you? Yeah? All right. So leaving all of the questions, I expect you guys to do it all over again. So let's look at number 19 one more time. Okay, I'm skipping, 17, 18 for you. And the number 19 is still the same drill, okay? So it says solve for x. Oops. When I'm in rush, I tend to make more mistakes. We want to have x squared minus 2x minus 3. We want to be greater than 0, right? So 19 through 22 are similar questions to 19 through 22 to the previous one, alpha 19. So the idea is the same. The idea is the same. Positive, we want a positive output. We want a positive or zero output and so on and so forth. Okay. So I'm going to take this time just to take this one. Okay, I'm going to take this picture. Hopefully I can, put the answers in place. Okay. But this time I'm going to remove that Y-intercept. It's not very useful out there. 0, -3, right? 0, -3, and I'm going to delete that. And I'm going to remove that dot, that point, 0, -3 from the marking. So you can see to solve questions like 19 through number 26, you really need, what you really needed is the X-intercept. Because that marks the positive, negative. That's the boundary between positive and negative. Okay, so once again, we're going to make this table for f of x larger than 0, right? For f of x larger than 0, right? For larger than or equal to 0, less than 0, less than 0, less than or equal to 0. It's pretty much the same drill, but you understand, once you understand the meaning, the answer is so obvious. Okay, the answer is so obvious. Okay, so these two, we need the dots. Okay, and these other two, we need the circles. All right, so I'm going to make the circles. Okay, so get the circles. Right? Let's get the circles there. Right? And then you just have to decide which piece will be the solution, right? And for greater than 0, we have these two pieces, right? We're running out of time. So the solution for these pieces will be here. Okay. And for these will be the dots and the bar. For less than 0, it's just the circles and the bar. And less than equals to, that would be the bar. You guys follow me? And that's it. And 23 through 26, there are these variations, and I have shown you some variations. So today's quiz, okay, if you don't get them today, you're gonna see them tomorrow. You're gonna see a quiz about these questions, I hope. So I'm gonna put the answers right here for closure. And that's gonna be x less than -1 or x is larger than 3. And the next one, of course, is going to be less than or equal and greater than or equal. And over here is a -1 less than x less than 3. And over here is a -1 less than or equals to, we're going a little fast over here because running out of time. I hope you guys get it. You can see the idea is completely the same. It's just a different example. It's just a different example. Okay, so your quiz will be on the lecture today and last time. Okay, so long. If you have any questions, please don't hesitate to ask. Okay, so please do not hesitate to ask. Okay, so you are going to have a quiz. You are going to have a quiz. Okay. All right. Any questions before we close? Any questions before we close? No? No questions? All right. I will see you guys on Wednesday. All right. I will see you guys on Wednesday. Have a great day. Have a great day. It's a beautiful day out there. Okay, so do take a break. And I hope to see you on Wednesday. I will see you on Wednesday. Okay. Bye.